Welcome once again to the UDIMKING Education Foundation. We are still on the topic temperature and its measurement. In our last class, we discussed the type of liquid required to use in the liquid in glass thermometer. We stated that the liquid must 1. Not wet glass. 2. Be opaque or colored. 3. Must have a high boiling point and a low melting point. 4. Must have a low specific heat capacity. And finally, 5. The liquid must have a high cubic expansivity. Imagine you've just built a brand new thermometer. It has the glass, it has the liquid, but it doesn't have any numbers on the glass. It means you can't take readings with the thermometer yet. How do you turn this blank glass tube into a precise scientific instrument? The answer lies in a process called calibration. Our topic of focus in this class is titled Calibration of the Liquid in Glass Thermometer. To do this, we don't just pick random numbers and write on the body of the thermometer. We need 2 unshakable anchors, 2 physical constants that will remain the same everywhere in the world. We call these 2 constant numbers, the upper fixed point and the lower fixed point. In this lesson, we will be calibrating our thermometer to read temperatures of water. So the upper fixed point is also referred to as the steam point, and the lower fixed point is also referred to as the ice point. Let's start with the upper fixed point. We need a way to find the exact point where pure water turns to steam. To do this with total accuracy, we use a beautifully designed instrument called a hypsometer. The hypsometer is a tall, double-walled copper vessel. It looks like a tube within a tube. To the left side of the outer wall is fixed a manometer. To the right side is a vent to let out excess steam. At the bottom of the hypsometer, we boil pure distilled water. However, for the purpose of this class, so that we can see what is happening inside, we will use a hypsometer designed with see-through glass. The uncalibrated thermometer is inserted from the top into the hypsometer with the bulb downwards, ensuring the bulb does not touch the heated water. Rather, it is covered in the steam. This is an important precaution students are to note. The bulb of the thermometer must not touch the water because the water may contain impurities which can affect the boiling point. We must rely strictly on the steam. As that water boils, it releases thick, hot steam that rises up through the inner chamber. We suspend our thermometer right in the middle of this rising steam. As the temperature increases, the liquid in the bulb expands and travels gradually up the stem. As this happens, the pressure in the hypsometer rises, causing the manometer to adjust as seen. This continues until 2 things happen. The red liquid thread in the bore stops rising, and the levels of the liquid in the manometer in both arms becomes the same. The water is considered to have reached its boiling point at this stage. The highest level reached by the red liquid is marked as the upper fixed point. Once that liquid stops moving and remains stationary for several minutes, we know it has reached thermal equilibrium with the steam. We carefully mark this level. Now, wait, before we mark it, we must follow 2 golden rules of the lab. First, the thermometer bulb must never touch the boiling water itself, only the steam. Pure steam is always constant. Second, we check our manometer. If the pressure inside the hypsometer is different from the atmospheric pressure outside, our boiling point will shift. We must ensure the pressure is balanced to get a true reading. Next is the lower fixed point, or ice point of the thermometer. We take that in the next clip.
UDIMKING Education Foundation. Building confidence, ending examination malpractice for a better tomorrow.
We are building a better tomorrow.
Join us in shaping futures through integrity and education.